Hi folks, this is Linear Algebra Quiz 15. We're asked to prove a theorem. Let t from v to w be a linear transformation. For v1 and v2 and v, prove that t of v1 equals t of v2 if and only if there is a u in the kernel of t with v1 equals v2 plus u. Now, this is a generalization of a theorem we have about the solutions to non-homogeneous systems of linear equations. Two solutions to a non-homogeneous system of linear equations are off at most by a solution to the associated homogeneous system. And that's really what's going on here. Okay, we have an if and only if statement. That's mathematical equivalence. That means we have two things to prove. We have to prove that if this is true, then this is true, and vice versa. Okay, so part one of the proof, we're going to assume t of v1 equals t of v2, where v1 and v2 are vectors in v and t is a linear transformation. What do I have to show? I have to show that there's some vector in the kernel of t so that this is true. Well, how do I get the kernel of t involved? Remember, the kernel of t is a set of vectors that give back the zero vector in the range, in the codomain. So, how do I get 0 involved? I can start with this equation and subtract t of v2 from both sides. That's going to give me the 0 vector in the codomain there, w. Alright, so now I've got the 0 vector involved. To be in the kernel of t, I need t of a vector to be in there, and I'm going to use the fact that t is linear. Since t is linear, I can rewrite the left-hand side as t of v1 minus v2. A lot of students like to say I'm factoring out the t. I don't like that terminology, but I say it anyway because it may help you visualize what's going on here, even though technically we're not factoring things out as a multiple. So now I finally have t of something equals 0. So if t of something equals 0, this means, or this gives, that whatever this thing is, v1 minus v2, has to be something in the kernel of t. That's by definition. T of this is the 0 vector, so that's in the kernel of t. Well, now I'm almost home. Because if I look at what I'm trying to show, if I subtract v2 off of it, I'm saying that v1 minus v2 is u, where u is in the kernel of t, and that's exactly what I have. So I'm just going to let u be this vector v1 minus v2. Then u is in the kernel of t, and v1 equals v2 plus u. Okay, so that'll do it for this direction. Now I have to go and prove the reverse. Okay, so now I have to prove this direction, which means I have to assume that this is true, and then I have to prove that that's true. So assume that there's a u in the kernel of t so that v1 is v2 plus u. I have to prove a statement about t of v1 and t of v2. What's the easiest way to get t involved? Well, t is a linear transformation, so in particular it's a function. So if two things are the same, then t of those two things are the same. So this is very analogous to multiplying both sides by 2, taking the square root of both sides, squaring both sides. It's a function. I'm just going to do the same thing to both sides. Now I'm going to take advantage of the fact that t is linear. Since t is linear, t of v2 plus u is the same as t of v2 plus t of u, because t preserves linear transformations. Now I'm almost home. All I really need to have happen now is for this guy to zero out, and then I have exactly what I want. That's exactly what's going to happen, because where is u? U is in the kernel of t. So by definition, what's t of u? It's the 0 vector in the codomain, the 0 vector in W. And more accurately, that's called the additive identity in W, and the additive identity in W does its job. This plus that is just that. So that'll do it for the second part of the proof, and that'll do it for quiz 15.